There are 8 teams in a certain league and each team plays each of the other teams exactly once. If each game is played by 2 teams, what is the total number of games played? So this is a question which we would like to categorize in either fundamental principle of counting or the number properties of permutations and combination. So I would like to discuss with you 3 different methods of answering this question. Now let's quickly see. Method 1, then method 2, and then method 3. So method 1 is quite simple. We'll start looking at this question from the principle of simple fundamental principle of counting. So let us see. If there are 8 teams, let's name them A, B, C, D, E, F, G, H. If A goes to play a match with every other team, the total number of matches that A can play will be 7. One match with B, then C, D, E, F, G, H. So 7 matches at first. Now all the matches of A have been counted, so we can just remove A from our calculation. Now B goes and plays a match with every other team, but since B has already played a match with A, so B will not play with A again. So B will have how many matches? 1, 2, 3, 4, 5, 6. 6 matches. Now B is also done because all the matches of B have been counted. Now C goes next and C will play a match with every other person, every other team. So there will be 5 matches more to play. And likewise 7, 6, 5, 4, 3, 2, 1. You need to just add them all. So either you can simply add them and the answer is 28, or there is a principle of adding consecutive numbers from 1 to n, that is represented by 1 upon 2 n into n plus 1, and here n is 7, so you can also write 1 by 2 times 7 times 8, which is equal to 28. That's method 1. Now let's look at method 2. Method 2 does this way. Now we have 8 teams A, B, C, D, E, F, G, H. If A plays 7 matches with 7 other teams, then likewise, if we look at every team independently, we can say every team will play 7 matches because every team has 7 other opponents. When we have 8 teams, then every team has 7 opponents. So every team will play 7 matches. But in this case, what happens is when we count the 7 matches of team A, then A has played a match with B. And when we count the matches of B, then B again plays with A. So when we say that every team plays 7 matches and the total matches will be 7 into 8 because there are 8 teams and 7 matches are being played by every team, then 7 into 8 considers these 2 matches separately. But in this question we have been given that each team plays each of the other teams exactly once, which means a match is being counted twice. Similarly, A plays a match with C, and when we count 7 matches of C, C again plays with A. B plays with C and C plays with B, so every match is being counted twice. And therefore, to eliminate the effect of repetitive counting, we have to divide it by 2 because every match has been counted twice. And that gives you answer 28 once again. So that's method 2. So we already know that the answer is C option so far. But now let's look at method 3 as well. What method 3 says is that for one match to happen, what is the requirement? Then the requirement is 2 teams because 2 teams, when they come together, they cause one match to happen, which means total number of matches will be equal to total ways of making different groups of 2 teams. Groups of 2 teams. We have 8 teams in total, and the 2 teams out of 8 can be identified in 8C2 ways. We are basically selecting all possible combinations of 2 teams out of 8. And that will be 8 factorial by 2 factorial, 6 factorial. And if you simplify this, 8 into 7 into 6 factorial by 2 times 6 factorial, the answer is again 28. This 8C2, if you want to just find it manually, then see the combinations of A will be the combinations of A will be AB, AC, AD, AE, AF, AG, AH. That means 7 teams. Then the combinations of B will be BC, BD, BE, BF, BG, BH. That means 6 combinations. So that way, basically the same calculation we are counting in just one step, and that way we are getting the answer 28, which is again option C. I hope these methods help you understand the concept in greater depth. Thank you so much.